Hey, yeah, what? Grab your bootstraps, yeah, let's scale your growth. Here's the truth, Jack. We'll reach the globe, unveil the notes.
Tanya, what
Learn
the
to pivot,
fuck?
earn your digits, won't burn, you'll get it. See, this is factual. Funds will show, learn to flow with Candid Capital.
This is a Candid Capital interview. In these episodes, we host industry business professionals involved in the global tech ecosystem to discuss various topics related to tech, global economy, and building sustainable businesses and investments. Welcome back to another exciting episode of the Candid Capital Podcast. I'm your host, Josh, and today we have a truly remarkable guest joining us, Dr. Zina Cinker, a visionary creator and influential figure in the world of material sciences. Dr. Cinker is not only the creator behind the annual Puzzle X conference held in Barcelona, but she also serves as the Director General of Matter Inc. With her extensive experience with startups, entrepreneurship, and investment in the material sciences field, she's here to delve into the captivating realm of the MatterVerse. Together, we will explore some areas of material sciences and discuss the possibilities of the future. We will have insightful discussions on the intersection of technology, innovation, entrepreneurship, and business as we gain a unique perspective on what lies ahead. And with that, let's dive in. Welcome, Zina, and thanks for taking the time to do this podcast with me. I've been looking forward to this for a couple of weeks to talk about all kinds of cool, exciting material science subjects.
Awesome. Thank you, Josh, for having me.
So just a little context for the listeners. We met at Mobile World Congress at the 4 years from now, and you were talking about all kinds of futuristic stuff with tech on the stage, and we had a short conversation after, and so I thought it'd be really cool to hear the things that you're seeing in terms of deep tech and where you see some of the magic of technology is going.
Awesome. Yeah, I forgot actually that's where we met. So thanks for the reminder for me.
Yes, I just after talking to you, I talked to the person who was doing the immortality talk, and so
Yes.
that was the
I would say.
event for that one. So usually how I start all these is I like to know the origin story. So how did you end up where you are now? What led to the type of science you've pursued and some of your influences?
Awesome. Yeah, how did I end up here in this chair? So I'm in Nashville. I will tell you how I ended up in Nashville in this chair. Since I was a kid, I always wanted to be um, an astronaut. And then when I was getting a little bit, I was in my teenage years, I wanted to be Bill Gates. So you can tell that it was the combination of wanting to be an astrophysicist, an astronaut, and being Bill Gates kind of led me down a path. I did do my PhD in fundamental physics and condensed matter. So my expertise is graphene. And I I also did my postdoc in the area of graphene, and then I started my first startup, which was, oh my God, this is such a different world than it is when you're doing work in academia and research. I was on a very exciting and adventurous kind of journey with having a startup coming from a very fundamental side of science. This wasn't I was not in an engineering department where you see startups left and right created, and then I basically started doing some very unsexy stuff, such as standardization, policy regulations, and I used to run the Trade Industry Association for Graphene, and that gave me a very interesting perspective of exactly what it takes to commercialize things. It was a very privileged position because I got a very inside, unique look at what it takes to do things. And then after a few years, I thought, you know what, we want to do something to look at the frontiers of what are called the MatterVerse, the world of atoms and molecules. What does it mean? What is the impact of all the development in the world of atoms and molecules on the next chapter for cities, citizen industries, and societies? So I started a think tank, a global think tank, which now has over 30 country chapters. And one of the things that we do is that we run an event in Barcelona called Puzzle X, which brings together the thought leaders from many different areas to look at frontiers of technologies all super cool things. I'm privileged to work with super cool people.
So, what was the startup that you started? The one that you're
Started
referring
started
to.
with very, very good question. It was on the area of graphene. It was around using graphene nanoplaylists, as well as graphene in the form of film, which is CVD graphene, in different applications in the industry. And as I was diving deeper into this field and with a startup, I realized that there are really big hurdles in front of the development of a nanomaterial company startup, and especially a graphene company. And one of the most actually interesting one was that at that point we did not even have a standardized terminology for what graphene was. So I started dealing with these hurdles and obstacles, and I was thinking, you know what, either I can do this and try to bang my head against this wall which existed for not me but the entirety of ecosystem, or I could actually start getting involved in the other areas, which are the unsexy areas I talked about, and try to see if I can help developing the ecosystem in a different way. So I got involved with the ISO International Standards Organization, and I still serve as one of the experts on the graphene terminology and standardization documents from the United States. So I started kind of getting involved more on the other areas that are hindering the development and the success of startups. So I changed path from going down this direction, seeing the challenges and saying, until these things are solved, I can bang my head against this and be one of the statistics of 1 out of the 99 startups making it out in the field of graphene, making it out after 5 years. Or I could actually get involved in solving some of those ecosystem problems that are really hindering us. And I chose the second path.
So I was just curious, do you have many patents in that industry since you spent so much
No.
time in it?
Actually, the interesting thing is that the concept of patents is a very unknown concept when you go to the fundamental side of science and physics. So to have a patent in a basic science field, it's very unlikely, because what you are focusing on is not really applications. There are no applications. I mean, the things that we were studying were, for example, my field of expertise was understanding how electrons and phonons, which are the vibrations of obviously the crystal lattice, interact in 1 femtosecond, a billion times a millionth of a second. For the listeners, and how does an electron interact with a photon or a phonon in that time scale? Then people would ask you, what is the application for this? The answer is there is no application for this. We're not doing this thing for an application. You're doing this to truly understand the boundaries and expand the boundaries of science. We do these things for the sake of science, not because there's an application. We're not trying to make something else better by doing it. These are exploratory sciences. As a result of that, it is not very common for the research to not have patents, or even the concept of patents being completely unknown to most of the graduate students who work in.
So when you were developing your startup idea, is it because you could not find an application for what you were working on? Because like usually with the startup, you have to have a problem to solve. Is that where what you meant by the block that you were facing?
So I was working on the area with graphene with some of the applications, but I was also in touch with some of the other areas of graphene where they were closer to some of the commercial applications. And there were some hindrance in terms of what can we do with this graphene that is coming out, and we were getting those questions. So the startup idea was around how do we actually make this process easier in terms of those in industry who want to use some of these applications or want to try something out with these newer materials, and being able to facilitate that. But again, when you're banging your head against the fact that we did not even have a common terminology for what graphene is. So what you would do is as simple as this. If you went 15 years ago and you search graphene on Google, which I'm sure that if you do the same thing, it's gonna buy graphene, right? Then you would see so many different things pop up. Some of them are in graphene in a form of a sheet, which is basically what we call graphene, what I call graphene in my field. And then there are these other ones that are in the form of a powder. And we do not call that graphene, but they're selling this thing. And some of these things are basically graphite ground up. So, but what do we call graphene? What is the standard terminology of calling something graphene? Are they wrong? Am I wrong? Who is right? And then you come back to the question of what is the standard terminology and name for graphene? Is it
Well,
one name?
I have the answer for you. Just let me ask ChatGPT. Just kidding.
Well, okay, no, talk about ChatGPT. Please, for the sake of everything, do not trust ChatGPT with the references. Have you seen what it does? I mean, I work extensively with ChatGPT these days, but what I've learned is never trust where it's getting the references. So I was asking a question for certain things around some quantum phenomena, and it was giving me references saying this is it. And then when I would go and I would search that reference does not exist. Also, we would ask it a question which is very, very basic question, and it would give you an answer that is completely wrong. And then I would tell him, I don't think that is right. And the common answer is, it comes back and says, yes, you're absolutely right. I'm so sorry. I made a mistake. Now that I look into it, the answer is this. Okay, so when you're looking at ChatGPT for these applications, please don't.
It's kind of like asking for directions in some countries. You always have to ask at least 3 or 4 people, and then you choose the one that is the closest.
Yes, when you're asking for something like this, ask ChatGPT twice. Say, I don't think you're right. And then you probably come back and say, yes, you're right. I had the wrong answer.
That's cool. Did you ever get into the space industry? I mean, clearly you haven't gone to space yet, but there's lots of time for that. But have you?
No, I didn't. Actually, no, space never really held that much of an interest for me beyond when I was like a much younger kid. What caught really my attention was the world of atoms and molecules. The MatterVerse is the most exciting one for me. I have obviously a cursory interest in what happens in the cosmos, as I think all of us. It's just fascinating. Everybody has that interest, but the extent of what we do with space is that we cover some innovation in space during our event at Puzzle X in Barcelona in November. But other than that, not really.
Yeah, I would say myself, I like it from sort of a commercial building point of view, but I don't want to ever go there. Like I like the idea of building spaceships and satellites and space elevators and whatever not, but I don't really want to, I want to stay on the planet personally. But maybe it's just because I think it's just not advanced enough for my risk profile, maybe. Would be it. But if I got a free ticket on the big rocket, Elon's big rocket, maybe, but only if he's going on it.
Oh, that's self-destructed. You don't want to be on that.
Yeah, no, absolutely. So, what is the MatterVerse?
Good question. Actually, I can connect that with what you were talking about before as well, which is, let's think about this idea of space travel, right? If you think in the context of we are sitting on this planet, and when you think in very, very long terms, long time scales, we are a sitting duck. We're sitting here and an asteroid going to hit this thing, like it's hit many times. And at that point, it could be completely changing the scale of life, the way that life exists. So you think about it in terms of the evolution of a species that is very smart and is intelligent. You have to get a way to be able to get out of this planet. And space travel is a way to be able to do that. So I think that this idea of us going to space is something that probably is an evolutionary pathway of us having to explore those areas. And we're not going to be able to do that without our mastery over matter. For us to get somewhere, we need to have the mastery over matter. We need to be able to work with atoms and molecules in a way that would be able to not only build rocket ships, but more important than that, these biological buildings, these engines this body we have is not meant to live in space. How can we change these things? It is, again, our mastery over atoms and molecules, understanding of our biology, and also being able to replicate that and change that is going to give us that opportunity. And in my case, the people that I work with and the thought leadership that we bring to the table is that we look at the pathway of space travel in two different ways. One is either we change our biology in a way that we would be able to live on in this long travel, meaning the longevity path, with Jose Cordero that you listen to. So there's a longevity path. How do we extend our lifetime? How do we actually rebuild and rejuvenate and regenerate? And with everything that we're doing with nanotechnology, with genomics, et cetera, which is okay, keep this body going, keep it fit for being in space. And again, all of these things are mastery over atoms and molecules, from pharmaceutical, from genomics. Everything that we're talking about is going to be in that direction. And then the other side of this is, okay, what if this biological building would never be fit for being able to be in space? So what do we do with that? Should we actually create means of us capturing unconsciousness and putting it in something and then travel? At that point, time doesn't matter. Scale doesn't matter. Biological building doesn't matter. And then that's when brain interfaces comes in. Those conversations that we're having about capturing the might of a brain, understanding of that. Again, material science. All of this is material science.
Yeah, no, that's interesting. Of course, I don't know. I can't even imagine that personally. I kind of just view it as, we seem to just be incorporating more tech into our bodies. So I just figured whatever we end up being down the line is probably going to be very different than what we are now. And we haven't even seen what's going to happen or what people will do with CRISPR. And when I travel and I go to these sort of health tourism places and they have all these different services that they offer, it's really interesting. How it's working out, I have no idea, but it's kind of an interesting concept. And then we had that, I can't remember his name, but the person from China that cloned the first human beings.
Yes.
And then edited them with the CRISPR kits. So, I mean, that stuff's kind of interesting. I mean, on the biology side, I don't know if you're seeing anything cooler than that you could maybe speak to. Yeah.
Yes. One of the areas that I've been focused on in the past couple of years and bringing more attention is that at our event last year in November in Barcelona, we connected from the stage to Australia to activate a bunch of brain cells sitting in a petri dish to learn how to play a game of Pong with us on the stage in Barcelona. This is not AI. This is a different kind of intelligence. This is a synthetic biointelligence. So now you're activating an organic matter, thinking matter, intelligence to learn, just like AI does, just like a synthetic artificial intelligence, which is basically a silicon-based intelligence, let's say, how it does. So that is one of the most exciting areas that is right now going on. And this organoid intelligence, being able to build these 3D structures with brain networking and neural networks, and being able to use that as a computational power.
Okay, so let's, again, I'm not a deep tech science person, so let me just try to unpack that so I might understand what you're saying. So you took brain matter, biological brain matter, and it needs to have a certain level of, I guess, cells and neural networks and whatnot, in order to train it to play Pong, or it intuitively just was able to play Pong.
The company, it's a startup that actually just raised another 15 million. So I'm so excited about that they are getting this thing, because at that point when they were doing these amazing things, they were actually there on the seed stage. Cortical Labs, they grow brain cells on top of a silicon chip, and that allows them and activate. And these are not the only ones. It's actually a budding and burgeoning field. They're able to train those cells by sending the electrical signals. At the same time, they're able to actually capture the electrical signals that these cells are producing. So it's a symbiotic relationship. It's at the interface of a silicon base and a biology base where this interaction happens.
So because it's not like a full brain, I'm assuming there's limitations. Like, would it only be able to be trained for like very specific tasks? Does it forget how to do the task, or
It
does it
does.
come
It
from?
does forget. Yes.
Okay,
It
okay.
does. So that's the thing, is that every time that once we wanted to do this first, it was in the world. This was the first ever time in the world that this was actually tested live on a stage. We didn't know if it would work because these are living cells. This is not something we know if this is going to work or not. And I had a lot of pressure from my from my team, and also from our decision makers and our board, to say, let's record this thing because there is a chance this wouldn't work. And we had media and everybody else that was like kind of coming in, and some of the decision makers from government. Everybody was in there. What I wanted to showcase was, this is live. This might not work, and if it doesn't work, it's also an interesting thing, because we are activating a completely new way of being able to do this, and you don't know if the cells are going to work or not. This is a new batch of cells. God knows how they're going to learn, and every time apparently you activate them, they learn differently. It doesn't mean that it's going to learn right now if we start playing with
Okay,
them.
so it's not like it's a clone cell from somebody who was good at Pong, and then we
No,
have
no, no, no,
a.
Oh, interesting though. But no, that wasn't. It learns live. So it started when we started seeing it. It starts missing. So it starts understanding, what do you want me to do with this thing? And it's just a fascinating thing. But no, I know that that's one of the things, is that it doesn't have memory.
So I suppose then you could probably use that to create a smarter robot. Like, if you're thinking
God
about
knows.
robot tasks, right? I'm just like thinking, like, if you're like the robots that they have, like the one they always showed, the Boston Dynamics, they're not that smart. They do very basic things. But I guess the idea of this, if you add some biology to it, it would make a smarter functioning robot potentially in
Wouldn't that
terms
be
of training.
amazing? I mean, that's one of the things that is really, I think, that is in front of us. And one of the reasons why I do Puzzle X is that I believe that there is going to be an emergence of many different fields for which we don't even have names, for which we don't even have descriptions. We don't know they're coming. And it's going to be at the interface of many of these exponential technologies that right now are going to be really booming. And we need to bring the thought leaders from different fields to come together and understand, where does it go? Because what if a smart car actually has a bio-based intelligence inside of it? What and Is anybody from the automotive sector looking at biology as a part of an intelligence to guide their navigation system or do something else? Probably not. How can we make sure that those areas that are developing in many different, very, very, very different fields, very far away fields, the thought leaders have a place to come together to be able to say, what is going on the edge, and how can we combine these things? What are the opportunities? That's where the interest for me comes in, and that's where, in the past few years, that's where I have focused my attention, is to make sure that that layer of development on the edge is visible to the thought leaders from the other side, and they are able to see that, and they're able to co-create these things. And at that point, maybe there is a synthetic biointelligence inside a Boston Dynamic robot, just like equivalent of a brain.
Oh, and then I suppose there'll be some sort of ethics question at some point. I mean, if you're using brain matter, I suppose. I don't know. But yeah, no, I never heard of this. Not that I would. As you might be aware, I mostly just deal in software. And so, one of the reasons that, I wanted to talk to someone in deep tech is because software advances at such a rapid pace, whereas the material science is much slower because it has different requirements and different constraints. And one of them definitely being funding, as a lot of it is funded by government and special interest groups. Whereas with software, you just really have to convince somebody they could make $1 billion and you can get some money. So for the companies that you see, forming as startups out of these types of deep tech, what would you say some of the difference would be versus, a software tech startup? What are some of the things that they would have to kind of look at for trying to start that versus that, because the speed is different with software and the expectations and the type of investors that you would generally attract have a different time horizon.
Absolutely. Good question. So I it comes back to us looking at the history of how innovation, science development, technology develops, and not looking at this period of time that we're in and the past 20 years is okay, we've known our life only in this past whatever period of few decades. But looking at the broader scale, and I encourage everyone to do that. Read about where we've come from as a species, where our technology development has changed the course, and it really gives perspective. When you look at it from that timeline, when you look at it from that perspective, you see that with our mastery over atoms and molecules in, I don't know, 60, 70 years ago, we opened a new door. With that first time in the Bell Lab with the silicon technology, the transistor, I mean, that was an open door to creation of a completely different kind of environment, a new world, a new universe that opened up for us, which is a virtual world, which is a digital world. All of that was enabled how? By our mastery over atoms and molecules. We went into the lab, we put a bunch of different things together, we created a structure that allowed us to have this. Once we opened that door, for the past 20 to 30 years, majority of our effort was spent on taking advantage of that door that was opened. So we opened our mastery over atoms and molecules, opened a door to a world of zeros and ones and code, right? Okay, wow, zeros and ones, code, fantastic. What do we do with this thing? So what happened was that we spent 20 to 30 years of truly mastering code. And that's what brought us here. Silicon Valley, the concept of Silicon Valley, I mean, there's no silicon in Silicon Valley. But I mean, this is a land of zeros and ones, right? All the startups in software, in apps, in platforms, et cetera, all of these things are mastered over not atoms and molecules, it's mastered over code. And that dies down. We have really extended everything we could have done. And the culmination of that right now is with artificial intelligence and machine learning. Fantastic. We did 30 years of absolute development. Why am I saying this? It's because I get asked a lot by to speak on the trends we're seeing. I do see a trend in the coming decade or two, which is going to be going back to the world of atoms and molecules and creating in structures that are really pushing the boundaries to open different doors. Just like our master over silicon opened the door to a world of zeros and ones, and then we spent 20, 30 years of developing that. Right now, the next chapter is going to be us mastering atoms and molecules for other things. Could that be in the world of consciousness? Could that be in the world of human augmentation? Maybe. And that will be different. So the pathway of us in the past few decades, it's been very difficult for the atoms and molecules folks, material science folks, to actually get funding for startups because the investment in zeros and ones has been a lot more lucrative. They don't have to, you can have basically a computer, sit in front of a computer in your garage and do everything you want to do and have a unicorn idea startup and try to do it. Try doing that with material science. Absolutely impossible. You need a lot of patient capital to be able to even start something, to be able to even start a prototype. So because the investment in that area has been so much less, because the focus was on something of us pushing the boundaries of software and digital world, the attention to atoms and molecules have been lower. But I see a good bit of opportunities opening up in the coming future, which is going to be us going back and saying, fantastic, we created AI. Look at this thing. It's creating everything we want right now. Now let's go back and push the boundaries of atoms and molecules, because right now with this amount of computational need that we have, you need quantum computers. You need a different way of looking at energy. This data centers we have, not working anymore. This kind of energy that we're expending, not working anymore. So you need to create a foundation that's going to be needed to keep up with this. So I think that things have been different for a reason, and things are going to be different again. We are starting a new era at this point.
So like as you said, a lot of it is still in the R&D phase of it. But which of these different verticals, you mentioned a couple like quantum computing, which ones do you think are close enough to the edge for the patient money?
Obviously, government spending is a major source, and I believe that it should be, of patient capital for anything that is in deep tech, because you can't expect industry and corporates and enterprises to put that money in. They don't. Their return of investment timescale is, horizons are very different. They think quarter to quarter. It's very difficult to expect and kind of anticipate that kind of patient capital to put into things are going to be coming from industry. So it's a job of the government to put the patient capital in for horizons of 20 years, 30 years. Quantum is a very important field right now. And the reason for that is not just because they're seeing potential, it's because the risk that quantum cryptography and having a quantum computer that can actually break through codes and security is causing. So that's where you are seeing a lot of interest from the governments coming in, is not just because there is a lot of potential in it, it's because of actually element of fear and preparedness. So
But
that's
with quantum though, you can see the path to commercialization. There's some attempts, there's some very, very specific use cases, of companies that are out there, but I would say they're emerging out of kind of the R&D space. My question is, of the other tech that you've talked about, and a lot of the different ones that are at PuzzleX or MatterVerse, which ones do you think are far enough along outside of the R&D space that it could be attractive to either corporate investment or commercial investment? Are any of them there yet?
Many of them are, absolutely. And everything that we talk about in a field like quantum computers, I mean, quantum software right now, there are applications, people are using them. And then we're having nanomaterials. There are many applications for them that are used. They're not very loud. We don't hear about them in the news because they are used because they're adding value. And that's when things are quiet, is that when corporate companies are using them, because there's actually absolute value in them. Everything is on a spectrum. There is an exploratory phase in every field, and then there is a phase where it's actually entered the market and people are using them. And then there is a phase where in the middle, for example, we're looking at graphene in concrete as an example, or graphene in brain interfaces as an example, where these are startups that are really doing well right now. They're pushing the boundaries. Are they $1 billion startups? Not right now, but they're on the path, and they're a really good investment. I mean, when you look at them, the opportunities for some of these things are really immense. So in every field, in the hydrogen field, in the genomics field, in pharmaceutical field, and in all of those things we're talking about, I don't know, CRISPR, things like that, there are immense amount of opportunities. It's how we're using them from the exploratory phase until something that's more commercial. And there's lots of different options on the scale.
Is there a particular, I mean, this is kind of maybe a difficult question to answer, but do you think there's like a key thing or nexus point of discovery that will kind of act as a catalyst for the next explosion of tech? Kind of like, we'll argue that AI has arrived and that's exploding in all kinds of different directions. But in terms of the material sciences, because being able to control things very small and being able to build things at different energy levels and whatnot require a certain advancement in the material sciences. So is there a particular area that you think that once we discover this is the one that's going to create the next wave of tech explosion?
It's already happening. It's machine learning. And quantum computing. I think these two things which are hand in hand, that will truly change the way we master matter. So for me, this is an exciting point. We've been waiting for it to happen, because we do have control over matter, of being able to put atoms and molecules together. I mean, we've got that. When we go into the realm of in the clean rooms and the way that we look at the fabrication and nanofabrication is done, we do have a lot of control. It's amazing how much control we have, actually. Um, what we don't have is understanding, the true understanding of how do we, when we put this thing and this thing together, what's going to happen. We don't have that knowledge. We don't have the simulation and compute power, our knowledge of being able to simulate what is going to happen. So what we do is, you've got a bunch of PhDs like me who go and do experiments. I would say, if we do this one, this thing happens. If we do this one, this thing happens. And we think that there is a trend and that there is a thing. But the truth is that we go into the lab and we do these things. Now, if I could simulate that, because I know exactly the properties of this one and this atom, and I said, can I simulate without actually doing the experiment what is going to happen? What do you think we would do? You would speed up this process to an amount that we could not even understand. Then you would have an answer, a tailor-made answer for how we understand how to tailor atoms and molecules. And at that point, then our drug design is different. Then our battery design and understanding is different. The way we design food is different. And that goes hand in hand with the computational power that something like quantum computers might allow us, and machine learning to be able to do that kind of work and understanding and be able to simulate those. So we are getting to that point, and there's going to be, when I talk about the world of atoms and molecules is going to be coming back, and it's just going to be an explosion. There's just that singularity moment that is going to be happening. It's because we're close to it.
So you heard it here. It's still zeros and ones. And
Sorry,
qubits. Zeros and ones and what is it?
Exactly, qubits. Absolutely. Zeros and ones. We actually start more talking about like bits, which is not quite known. More people understand zeros and ones better than bits, but yeah, bits and qubits. That's
okay. So that'll be the big deciding factor. So the next thing I wanted to kind of just jump into, because it's your area and I really don't know very much about it, and that is the graphene. I've only really heard of it in terms of different materials for renewable energy plays. I guess talk about batteries and solar panels and things like that. So I was just thinking this would be a great time to kind of just learn from you. What is it? What is so special about it? And why is it such a, I would say, an important material?
oh,
in terms of
global
tech, in
graphene.
terms of tech
For
tech
sure.
and the future and all the cool magic that we will have in like 10 years.
Yeah, that's my area. Cool magic stuff. No, I mean, graphene is really magical. When, as a physicist, it's very interesting. Doesn't translate when we're talking about the commercialization of it, but as a physicist, when you're looking at it, and the reason why I didn't do astrophysics and I did graphene and condensed matter physics was because I just heard about this material. It's one atomic layer of carbon, and it is the thinnest and strongest, one of the strongest materials we've ever known. I mean, it's 200 times stronger than its equivalent weight in steel in that one atomic sheet. So it's really fascinating when you think about it. And it's at one atomic layer, it's transparent, it's flexible. And the most interesting thing is that atoms electrons in graphene can travel with the speed of light in crystal. I mean, this is fascinating. It has very unique electronic and thermal properties. I mean, these things were, for a physicist, is like, oh my God, what is this thing? This is like, you say Santa Claus is real. When it happened, it was really that moment when it was first isolated in 2004. It was really that moment. It won the Nobel Prize 6 years after its discovery. This is not common. You don't win a Nobel Prize. I mean, lithium-ion batteries, how many years? 40 years after. It was that significant of us finding a material that is stable and exists in a truly two-dimensional form, where the physics that inhabits this planar existence is different than the physics that is in the three-dimensional stack of something like everything else that we deal with. So it opened a new door of discoveries of us saying, wow, something else. So this world exists, this two-dimensional world exists, and pushing the boundaries of understanding of physics, chemistry, and all the different areas of science behind this. And just like anything in deep science and frontier tech, when something like this gets introduced, people get way over themselves. It's like, oh my God, this is going to change the world. Then there's a bunch of startups that go out there and make absolutely ridiculous claims. There's also absolutely ridiculous claims made by the media, caught in the frenzy of this thing. And then there is this whole Gartner hype cycle, which goes up with the hype, goes down to the trouble, disillusionment, and like this is a winter that is happening, and then it just picks back up. When I say it goes steadily, and I say when it's quiet, it's good. They're using it when it's quiet, is because you're using it when there is absolute need for it. You're using it not because it's a marketing term anymore. So graphene has gone in the past 15, 20 years, has gone through that period, and it's now coming out of its uses, where it went really through the hype and then it went down to saying, oh, why is this thing not delivering? And every time that I used to run the Trade Industry Association for graphene, and everybody would tell us, why is this thing not delivering? We're supposed to be having flexible phones by now made of graphene. And I would say, what were you expecting? Whoever told you that we were going to have these things were out of their mind. It takes 20 to 30 years for any development in deep science to even make it to commercialization. So in that path, graphene is very much on track. It's happening faster than we expected, but you have to expect 30 years at least after a truly groundbreaking discovery for the commercialization aspects to pop up.
So what I'm hearing is we shouldn't make robots out of this material.
Yeah, you should absolutely make robots out of this material. But right now, we've put 20 years into this thing, so it's good timing if you want to make robots.
Okay, we shouldn't put free thinking robots into a graphene skeleton, maybe.
Why not? I mean, what for me, what is the interesting thing about graphene is that you mentioned batteries. So what are the other applications of graphene? The thing is that graphene is such a versatile thing that it also acts as like it's a blessing as a curse, because people say, where would you use graphene? I say, depends what sector we're talking about. I mean, we're seeing right now graphene being used in concrete, and it is this graphene powder, not the single layer, atomic layer. Graphene nanoplatelets and graphene powders, flakes that are being used, it results in 30% less CO2 emission in the process of making the concrete and cement, which is significant, with addition of very small amounts of graphene powder, like 0.05% adding as an additive to be able to have 30%. This is fantastic. I mean, but is it super sexy? Well, probably not. But then there are other applications of it. That what excites me most about graphene is in the area of brain interfaces. Graphene is a material that can be stimulated and can also record at the same time, which is it's a semi-metal. It can be a semiconductor in a certain state if we open a band gap, and it can also be a metal.
Well, the first thing that comes to mind is this Wolverine's adamantium?
I don't know what that is.
I don't know if you're familiar with that Marvel character, but
no, I'm not.
His skeleton is made out of an indestructible metal.
That's the graphene. That's one of the misunderstandings of people thinking that if you have something with graphene, you can make an armor. No, we're talking about in one atomic layer thinness, it's stronger. But graphene is only one atomic layer. It is very strong.
For sure. But you mentioned that you could mix it into concrete to make it, really good. So if you mixed it into somebody's bone, would you have that's the idea anyways. That's the idea of Wolverine is, his skeletal structure gets injected with this type of liquid metal that's instructed.
How interesting. Okay. So, probably wouldn't happen so much with graphene. First of all, graphene is black. I'm not sure how that's going to work in your bones if you're trying to think of bones, but it's interesting. It's a very interesting field for people to think about, and kind of for the scientists to look into some of these more sci-fi applications, and they're doing it. I mean, one of the examples of very fascinating things that was done with graphene was from James Tour lab from Rice University years ago, which was they had a mouse with a severed spine. The spine was completely cut off, and they add a little bit of graphene nanoplatelets to this, and then the mouse starts walking after a few weeks, which is fascinating.
See, Wolverine, I'm telling you, this is the stuff.
But let me debunk that thing to know this is nothing magical about it. Basically, what it is the magic of the body and the biology itself. What graphene nanoplate is, these little flakes of graphene in this scenario are doing is that they are creating the pathway, a very good surface for the neurons and for the already existing biology of our body to grow on this, so they can find each other. When nerves find each other, they will trim themselves, and they will actually connect and rebuild. The thing is that when something is severe, they can't find each other.
So do they use this stuff for like when you get a compressed plate in your spine, there's a lot of different surgeries that you end up getting it like removed, or you get like a plastic piece put in there. Is it being used in that application?
I'm sure that somebody's working on that. I'm not up to date on that, but I remember years ago, 7 or 8 years ago, people were working on that. They were working also in dental implants, things like that. In this case, I'm talking about, it was the platelet of graphene powder basically was giving these dangling basically nerves a place to sit. And because in an immersion and dispersion of these graphene nanoplatelets in like a water or whatever the medium is, there are many of them, these nerves have a way, and they like being on graphene. Graphene is made of carbon. It's basically carbon. It's a one layer, atomic layer of carbon, and our bodies are made of carbon. I mean, this is a very bio-friendly material. The body likes, the neurons have been shown to really like being on graphene. They've got a very secure and happy electrical signals rather than graphene. So if they like being on this thing and they find it and say, I can grow on this, and then the other ones are growing, at some point they will come and meet each other. And the way that these two things get connected is nothing to do with graphene. This is a magic of the biology itself. We're just assisting it to find each other. But the result is this: mouse with severed spine who would never walk again is now walking. So,
well, I mean, the other thing that I get, you're talking at a more like the particle level, but when you think about all the different implants that you get and the rejection or the pills that you have to be on in order for those things to work, so that's kind of an interesting concept if it ends up working that way, to make those surgeries or abilities not to reject the implants or whatever it is you have in there. That's cool. So the other thing that I wanted to ask about is nanotubes. Nothing specific exactly, just because in terms of sci-fi, I just love the idea of space elevators. And so the only thing I know about space elevators is you need nanotubes. So that's why I wanted to talk about nanotubes. If you could just talk about it just a little bit, about what it is, where it's at, where you might see some of these cool things, just like you did with the graphene. You don't have to talk about space elevators.
Nanotubes, but the idea of space elevators, goodness gracious, I can't wrap my head around that. I don't exactly know what these folks are thinking. I'm sure that there is something that they're thinking. I wouldn't be the person to talk to about space elevators.
There's the largest construction company in Japan has a proposal for it.
That is amazing. Do you need to send me some? I mean, I know people from the graphene community who are involved in the space elevator community, and I know that they're doing that. I just do not exactly know what direction they're taking.
Yeah, well, I mean, all I really know is that they can project when it would be possible to build one based on the progression of nanotube tensor strength. I believe that's the concept. And that's why the proposal is to build it in 2050. based on the advancements of the tensor strength of nanotubes, apparently. Again, I'm not working on this, so I don't know, but I am a fan of Arthur C. Clarke, and he wrote a whole book. I think it's called The Foundations of Paradise, where the entire thing is about building a space elevator and the
I read that.
Okay, so that's what pulled me in, was that book, because it totally makes sense, all the problems they had in it politically and then technologically, and it just seemed like a really cool idea because we're racing for space mining. Whoever has the elevator wins, probably.
My answer is going to come from two things. First of all, never spend the time to actually understand exactly what the space elevator community is talking about when they talk about graphene or carbon nanotube in that. And the second one is that I used to grow graphene and carbon nanotubes in the lab. And even the conceptual thinking, because if they're relying on the strength of a single nanotube to be able to, which again, come back to my first point, I don't know exactly what the scheme is here. If they are thinking of having single nanotubes that have that kind of strength that could be built up with that, I've got like just a immediate reaction of saying, when on earth are we going to get to the defect-free state of these things? Because the tensile strength and the strength of graphene also, when we talk about it, only is in the scenario where there are no defects in the lattice. The moment you introduce one defect in the lattice, the whole thing just falls out. I mean, this wouldn't be possible anymore. So I'm interested in, hey, anybody from the space elevator community, come and talk to me and tell me what is happening. Please inform me what you guys are thinking. Yeah, for me, again, as somebody who has been growing these things and working on reducing the defects, it's very odd for me to think that we would be getting at a point where there is this idea of us being able to control it to that extent. But then again, if the timeline is not in 2030 and it's in 2050, yeah, why not? Maybe that's possible.
I just thought it was a really interesting concept. And again, like I said, I think the book outlines a lot of other problematic areas that have nothing to do with the technology. But I thought it was like really interesting because, there's only one place that can afford to really fund it, and then where you put it, because you can't build a space elevator, I think, anywhere is the concept. It has to be built in some way related to orbit. And I don't even, like, for myself, I'm always just thinking when they're describing it is like, what do you do on the other end? Like, like what goes on the other end of the elevator? But you see it in sci-fi movies.
On a deck. Imagine if we just sit on a deck with our, like, I don't know, with a cup of coffee or with a glass of wine, and we're just looking at the cosmos. It's like, so glad we made it up here.
Well, it would be a cool like thing to do, kind of like people going in a hot air balloon, and you go up in your spinning restaurant and then you come back down.
Yeah.
I mean, it's probably just like space now, right? Their customers are either government or tourists, for the most part. But I also think, it's interesting if they were to try it in a real way, because just like the people who think we shouldn't launch rockets and we shouldn't have a space program, there's a lot of tech that comes out of that. You just don't get it immediately, and it's really expensive. But a lot of that stuff gets discovered along the way, and then it trickles down into other applications, whatever they're going to be.
That's maybe a good closing point in here, which is, if you look at the development of our species, again, let's look at the timeline longer than a few years as ahead of us. Look at us. We are such a new species. People think, oh my God, why is our things not happening so fast? We are so new. It's been 6,000 or 7,000 years since we started learning to even just write or have means of storing information in this capacity beyond our auditory and memory. The fact that in the past 100 years we've come this far just tells you where we might be going. If you go back and 500 years ago and you describe any of the things we're talking about right now, these concepts would be outside of the realm of understanding for someone. 100 years from now, it will be outside of our realm of understanding of what we're talking about here. We wouldn't even have the language, we wouldn't have the understanding, we wouldn't have the foundational capacity of conscious of understanding what is going on. We are a very young species. We've had immense amount of development. Where we're going is not just a matter of what funding is available, but it's also a matter of where the humanity as a whole is picturing itself to go. So I have no doubt many exciting things are going to go on. Whether or not be space, it would be longevity for us to live until we're 200 or being immortal, or us mastering every atom and molecule in the cosmos and make them into quantum computers, or we become semi-gods. God knows what happens. It's exciting.
Oh, absolutely. That's super cool. So we're coming to the top of the hour here. So let's move on to kind of just my random questions. So what are you currently reading? And if you don't read, listening to, if you do audiobooks or podcasts or something like that.
Okay, I'm reading a book by Sir Roger Penrose, a Nobel laureate, the mathematicians, and The Road to Reality, something reality. I have to check it. Gosh, this book is so intense. I mean, I'm a physicist and I'm reading this thing. I'm saying, oh, who reads this thing? This is so difficult to understand. But it's magnificent. I mean, he's laying out the language of mathematics and connecting it with the reality of our world. And it's a very heavy read, very, very heavy read. But it's very exciting. And I'm also going to be meeting him in a few weeks. So I'm excited to be reading that. The other book that I'm reading that if people are listening, read this thing. It's by Bobby Azarian, one of my friends. He talks about complexity science and how we are basically creating a global brain. I mean, this is, if you're interested in sci-fi consciousness, I don't know, complexity science, where are we going with the cosmos? We're creating a bigger consciousness, bigger connected global network.
Is this the idea of the internet being the neural network brain of
Oh,
all
yes.
human
And
beings?
Bobby goes outside
Yeah.
of this. I mean, Bobby goes and projects these things into the, I don't know, the immense future. And he's got some amazing perspectives. So I love his book. The name is Romance of Reality. That's another book that I'm reading in conjunction.
Okay, that's cool. The last question, and I mean, it's if you have one offhand, but if you have a favorite quote you'd like to close with.
Ooh, what's my favorite quote? What's my favorite quote? There is one by Nelson Mandela that I actually say, but I'm not gonna say it. I think it's him saying, it's deemed impossible or something until it's done. It's again, hey, I'm gonna be butchering something right there.
Oh, okay, yeah. I think I know what you're. Oh, I think I've used this one recently. I don't. I'm trying to remember because I think it was actually at 4 years from now about
It
the
was?
metaverse. Yeah, someone quoted it about something in relation to the metaverse, of it being a lot of like people. I'm sorry, I can't remember
It
it, but
always seems impossible until it's done. Now we've actually
yes,
given the right attribute.
yes.
I will not butcher this thing. That is one of my favorite quotes because truly a lot of things that I have done in my life, people would say, that's not going to happen. People are not going to come together to do this. This is not going to be done. And you say, you know what? Maybe not, but I'm going to give it a try.
Why not?
Why not?
That's what I always say. Like that's what we're in the, well, at least, we're in the startup world, and it's always about, try, correct, try, iterate, like why not? So I think that's a great quote to end on. And I'd just like to say thank you for doing the podcast. And if there's anything you would like to tell the audience, promote, this would be the time.
Thank you so much for having me. And if there is if part of your audience is fit for Puzzle X, and if anybody's who's listening to this is not in the field of purely code and zeros and ones, or your code of zeros and ones has an impact on atoms and molecules, let me know, and we could see kind of if it's a fit for Puzzle X in November in Barcelona, where we bring together everybody who is actually pushing the boundaries of possibilities for the future.
Perfect. Thanks.
You can find information about the Candid Capital Podcast on the website, LinkedIn, and Twitter. Episodes can be found on Spotify and other podcast platforms. A quick reminder that this is infotainment and is not intended to be professional advice, malicious, or hateful. The views, information, or opinions expressed during the podcast are solely those of the individuals involved and do not represent those of employers, partners, and their subsequent connected private and public associations or organizations.
We candid, I hope you understand it. Your business growth, we planned it, yeah. This ain't for show, we stamped it, yeah. No FOMO, everyone come join, no solo. This all factual, from me to you, this Candid Capital.